Hello everybody and welcome back to another Max MSP tutorial. I am Andrew Robinson and in this video we are going to talk about Jit.world. It is your world made easier and it is a tutorial video I've wanted to make for a long time because it really does make your world easier if you're trying to do visual stuff. I've been putting it off though for like kinda a second because it's also a little confusing to wrap your head around if you're new to Max, but have no fear, I'm gonna do my best to break it down and explain the differences and why Jit.world is both so easier and a little bit more complicated. First things first, we have to create the Jit.world object, which when you do that, it's going to give you this beautiful window that we can see things in. We've talked about this in many videos already. Jit.world is very similar to jit.window in that they both create these beautiful visual windows for us to view things in. The key difference between the two is jit.window operates on the CPU, and jit.world uses the OpenGL rendering engine, which is just a different rendering engine for visuals, but it operates on the GPU, which is our graphics card. So if you've got a really nice graphics card in your computer and you do visual elements with jit.world, it is going to run so smooth and so clean and you won't see any frame drops or anything. The more powerful your graphics card is, the better your stuff will be if you use jit.world. I can't necessarily say the same for jit.window. I've done some example videos with jit.window showing it because there are some basic components of Jitter that you have to wrap your head around. Check my intro video where I talk about that stuff. But once you've got a good handle for needing to send bangs and things to get video playback and frames, whatever, all that jazz, you can just dump the jit.window because Jit.world is just so much better. It is a jit.window, but with more. And it allows us to do things in 3D, not just 2D. So that's super cool. And with it, just the world is opened up to us. So let's talk about some attributes that help make Jit.world the best object for doing visual stuff. Aside from the fact that it runs on OpenGL and you can get really great frame rate from it, we can do some things to make it look really nice. We'll set some attributes up. By default, I always like to have floating 1 on there so that way this window does not disappear when we click away from it like it just did. And then I also like to include at FSA1, which stands for full screen anti-aliasing, which means when we go full screen, everything will just look nice and clean. And this is a really nice feature of Jit.world also that I'm going to talk about. When we are in full screen, you can just click on that window and press the escape key and bam, full screen. It's black, nothing's showing right now, but we're full screen mode. If you have Jit.window, not world, we don't want two worlds, we want a Jit.window. To show how bad it is. We're going to click on this Jit.window and press the escape key. It's not working. It's not going full screen. We can go full screen with the Jit.window, but we have to actually code that into our Jit.window. With Jit.world, it's already there. You don't have to worry about coding full screen or anything. Let me tell you, that saves a lot of time. There are many projects I did when I first started. I used Jit.window, went full screen, didn't give myself a way to get out of full screen. So Jit.world, way better for that reason alone. And speaking of full screen, there's this other attribute called FS menu bar. We're going to set that to 0. So that way when we go full screen, it won't show the menu bar in the window, which just is a nice clean presentation. And this, by default, are just like the basic settings I like to have in Jit.world if I'm like jumping into a prototype. But there are a few other things we have to talk about. First off, this window is black. And that's because the OpenGL rendering engine has yet to be turned on. There are 2 ways we could do this. We could create a toggle by pressing T, patching it into the Jit.world, locking our patch, clicking it, and turning it on. We sent a 1 from this toggle out through this patch cord into the Jit.world, and now that tells it to turn the rendering engine on, and we know it worked because it went from black to this slightly gray background. That is the default background color for Jit.world. We can change that with the erase color attribute if we wanted to, but it's default gray, and this lets us know it's working because it changed color. So that's a good thing. The other way we can do this is simply by using the enable attribute. If you say @enable1, this is going to automatically load the Jit.world to be on. So you wouldn't have to attach this toggle and click it. It's just ready to go. Although I will say it is nice to have this toggle button here into the Jit.world that you can click to turn on and off the rendering engine simply because sometimes when you start doing visual stuff and you get really complicated with how you're processing pixels and pushing them around, you may be doing something that is going to drain a lot of your frame rate data. And if it starts getting really bogged down and slow, it's going to be harder to program things. It'll be hard to create objects and type stuff into it. You see it's already lagging because I'm screen recording a little bit. So just generally, it's nice when that happens to be able to turn your visuals off and then do the code because it works a little bit faster. So that's super nice. And with that, we can talk about even more important things with the jit.world, which is very important when it comes to creating the visual element. It's super helpful to be very specific with certain things, especially when you have to create a visual element within certain conditions. These conditions that I'm talking about are our dimension size. By default, the jit.world dimension size is 1280 by 960, but we can change this with the dim message. So if we wanted to, do like 1280 by 720, which is pretty standard aspect ratio size, we can set that in the dim message. And now our internal dimension of this window is the same as this. You'll notice though, the window size itself did not change, which could be good or bad depending on your preferences for things, but I would say it's always nice to have the window size be half of our internal dimension size. That's kind of how Max has things set up by default. I said the default dimension value is 1280 by 960, and the default size for this window is 640 by 480, which is half of that. So we can do the same thing, and if we set the size attribute to be half of what we have defined our dimensions as, so in this case it's going to be 640, 360, it's going to shrink the size of the window, but now we have the proper aspect ratio. So this is exactly the size and dimension and aspect that our videos are going to actually render in based on the dimension setting we have set for this jit.world. So that's super important, and it's nice to predefine these things at the very beginning if you know what these settings need to be, because it's going to help in the long run when you start getting into the actual visual programming things. And that is a great place with the dim size and the size of the window. The last thing we want to talk about here is our frame rate. Frame rate is very important when it comes to doing visual stuff, and we can check our frame rate using the jit.fps GUI object. That's FPS GUI, I like to call it. And if we attach the middle outlet of our jit.world, which sends a bang, this is just sending out a bang every time this frame is redrawn, we can attach that into this object, and it's going to read out our frames per second, which is pretty nice. And by default, depending again on your graphics card, things you're doing, it's going to default to 60. It's probably running a little bit under 60 right now because, again, I'm screen recording, so that's kind of using some of my computer's power to record. But the fun thing is with this, we can always, not only can we check our frame rates per second, but we can also change how fast we want things to render at. If we wanted it to render at 120 frames a second, we can do that. We have to say sync 0 first, though. Sync enables vertical syncing. What that does is it syncs the refresh rate of our jit.world to the monitor's refresh rate. But if we set it to 0, it's no longer synced. So we can define things independently that way, which is super helpful if you are trying to increase the frame rate. And we could say FPS 120, and then it's going to do its best to output 120 frames per second. And you can see it's sort of getting up there. We're hitting about 90, now over 100. If I wasn't screen recording or anything, if I was just running Max Plane, this would definitely be hitting 120 frames per second right now. My graphics card is not that great even. As soon as I try to do anything, it's going to dip back down. But theoretically, this is possible, and if you have a great graphics card, you can definitely do 120 frames per second visual type stuff if you wanted to. The power is in your hands. This is just how you're going to go about setting it up. And we have the enable 1 turned on, so this is already rendering, which is nice. I'm going to turn this toggle on just so that's clear that we are in fact on right now. And now we just have to send visual stuff to this window. So we've talked about this a little bit before in previous videos as well. With jit.window, you have to send it to the inlet of the window. That's this little guy right here. It is not the same case with jit.world. We could attach the video output into this inlet, and it will show up here. But because this works as like an open 3D world where we can have a lot of video planes or something, or 3D shapes in video planes, and just it's basically a 3D world. We can throw anything in it. It has the ability to render video planes and such without necessarily having to patch it directly into the jit.world object itself. The object to do that is jit.gl.videoplane, and if we give it the attribute at transform reset to, it's going to stretch to the borders of this window, which is really nice if you are just trying to work in a 2D environment. If you wanted to move this video plane around in 3D space, which is definitely something you can do and something we'll talk about probably someday, you probably wouldn't want that transform reset to there. But it's nice if you are just thinking in 2D. And then we're going to create a jit.grab, which is going to open up the webcam on our computer. And if I do that, the cool part is it's just going to work. There I am in the webcam. You can see me now. Hello. And I didn't have to even send a bang to this jit.grab. If we were using jit.window, this jit.grab would have to have a bang in order to output every frame. But because we're using jit.world, I don't have to do that. It automatically knows that because this is attached to an OpenGL object, a jit.gl.videoplane, to just automatically output its frames without needing to receive a bang, which is super cool and a lot simpler if you're trying to do kind of like webcam real-time stuff or video playback. Excuse me, trying to do video playback. It doesn't need bangs to work, which is super nice. It just works, which is awesome. And now, the world is our oyster. But we have to start to be careful about things because we are working in this OpenGL context, which I keep talking about. And it is slightly different from just your plain old jitter context stuff. With, right here, we are outputting a matrix through this patch cord into an OpenGL video plane. And with that, we can, throw in all these cool jitter objects to do things. If we wanted to, patch the rota in here and out to the video plane, and then, I don't know, throw an offset X or something, offset X or something, offset X or something in there and start moving that around, we can do that because we're working on the matrix context right now. But OpenGL does not work with matrices. They are technically matrices, but we call them textures when it is OpenGL. And it's so much cleaner because you get better frame rate data if you're using textures. The issue is our jitter objects don't work on textures. And let me demonstrate. We can patch an adder UI in here, which I created by pressing the A key on my keyboard. And if we go down to output texture, we can send this jit.grab matrix out as a texture rather than just a regular jitter matrix. And now it broke. And the reason it broke is because this is now outputting a texture, and jit.rota doesn't work with textures. It doesn't work with textures because they are within the OpenGL context. And if I open up my Max console right here, it might take a second to load because it's bugging out, but you're going to see it doesn't understand the OpenGL texture anymore. It says jit.rota does not understand jit.gl texture. It's telling us that that is an issue. That is why it's broke. If we just remove this jit.rota from the patch cord chain, then you'll see, okay, we have the video back, it's working now, and we are outputting a texture, and actually this frame rate went up because we're using it as a texture, which is super cool. But how do we do editing stuff? Like, how would I rotate this video plane right now if I wanted to, if with textures we don't understand jitter objects? I can't use jit.rota to rotate this because it doesn't work with textures, so how would I rotate it? It's kind of a tricky question, and kind of for that reasoning, I do like to keep things as jitter matrices until the very end, which is probably not the best in terms of, getting high frame rate values, but it does make things a little bit easier to program. If, however, you did want to keep everything as an OpenGL texture and you wanted to rotate this video as a texture and not use jit.rota because you're going for the highest frame rate possible. Thankfully, over here in this video plane, we have a lot, or window plane, we have a lot of options for other types of objects that work in Max. Down here is the Visi button, and with the Visi button, we have all these cool video effects that are objects that actually are, if you're using the newest version of Max, they should work with OpenGL textures. And we can do all kinds of cool things with these effects on GL textures. There's this object, Rotar, which you just click and drag it in, and then we could patch the jit.grab through it and it out to the jit.gl.videoplane, and sure enough, I am now able to rotate this video even though it is a texture. This object works with OpenGL textures and it does the same thing. It allows us to rotate, and we're still getting pretty good frame rate values. And that's awesome. And these objects are super useful too because they have inlets that let us control these parameters of the object. So for example, the rotation, actually I have to use a float number box because these are also normalized, which means it's going to take a value between 0 and 1 to determine the output of whatever parameter we're changing. So you see I'm patched into the rotation inlet to control this rotation parameter, and as I slowly start to drag this number up towards 1, we are slowly getting towards the full rotation. So we could automate this if we wanted to and just have it rotate forever, or you can click drag. It all depends on kind of what you're going for, but that's how this works. And if we go past 1 and you just notice it's going to wrap back around, I don't know if every single Visi object will do that, but it does work pretty well in this context, which is pretty nice. And similarly, we also, we have offset X with this, we have offset Y with this, all the fun jitter rota parameters we know. We can fold and get a cool mirroring effect, and again, still super high frame rate with all this stuff, which is very nice, and will let you create a lot of clean, high quality, high dimension videos. And that's pretty much it in terms of what we can do with jit.world. Hopefully this is clear at this point, why jit.world is so much more valuable and how to sort of circumnavigate some of the issues you may run into with jit.world and the OpenGL context. You got to remember your regular jitter objects don't work, but we have all these cool Visi objects that will work with OpenGL textures. And I don't even know, I'm going to be honest, I don't even know what half of these do. I'm kind of going to start just experimenting. We have Scrambler. Let's patch this in. Let's see what that does. Oh, it's that's pretty sweet. And this is just the beginning of the visual book that is visual elements and OpenGL and Jitter and Max. There's literally so much that can be done here. Real quick, the last thing I think I want to show before I sign off on this tutorial is what if we wanted to record this sweet video output? How could we do that? Well, we're going to go back to our jit.world object itself. You see this outlet over here, it says texture or matrix output if enabled. So we're going to enable as an attribute output texture. And now it's not going to change much here. This all looks the same. But out of this outlet, it is now outputting the video texture. And that is the best way to record the final result of whatever visual element you make, because everything, whatever you're coding and stuff, it's all going to be drawn into the jit.world and mixed together as a final world output, and that will come right out of this outlet, and we can record that. To record things, I like to use the Siphon package. That is a package you have to download, so you got to click on the package manager icon to open up the package manager window, and it might take a second, especially if you're screen recording like I am, but eventually this window is going to load and it's going to show a bunch of packages that we can download in Max that are just extra objects that other people have created that are super helpful for doing things. And one of those packages is the Siphon package, and that is SYPHON If you are on a Windows computer, it's Sprout. So that's an important difference. Siphon is for Mac, Sprout is for Windows. But these are essentially the same thing. And you're just going to click on that Siphon package. And if you don't have it installed already, once you click on it, you're going to click install. I already have it installed, so it's saying uninstall. Wow, this is really lagging. I apologize. But eventually, there it goes. It's going to show up. You're going to click install. It's going to ask you to reset Macs, and then it's going to reset Macs and do everything. So make sure you're at a good saving spot before you do that. And once you do that, you're going to have this cool new object in Macs called jit.gl.syphonserver. And oh my god, this is what I'm talking about. So I can't code anything right now because the frame rate is it's just using so much power to just draw these visuals. So if I can, get to the point where I can turn this world off there. Wow, look at it go. There we go. Okay. I'm going to turn the world off for a sec so it's easier to code things. You see now how much faster that is. And if we just attach the output here into our jit.gl Siphon server, this is going to create a server that is now hosting that video that all Siphon applications can understand. And Siphon is a really great video application, especially if you're trying to do like multi-program stuff. Like maybe you use Resolute and you want to read a max patch into Resolute. You can do that with the jit.gl Siphon server because you can use the Siphon server in both Resolute and Max. It is also a great way to record. Once you have this object, the jit.gl Siphon server, and we are sending this texture out through this patch cord into our Siphon server, you can go to the Siphon website and download their Siphon Recorder app. It looks like this. I have it already down here in my Launchpad. Going through, it's Siphon Recorder. It's right there. If we click that, it's going to open up this window, which ignore what's being drawn in there right now. That's not super important. If we turn this back on, that texture is now outputting into the Siphon server, and we can see it in our Siphon Recorder window. And we could just click down here and click record and record the video. But you can also go to preferences and make sure that in the preferences, your frame rate matches your frame rate out here, and your dimension size here matches the dimension size up here. And if you do that, if you make sure those things are correct, it's going to look way better and record way better out here when you click this record button. You can click snapshot to take a picture. There's a lot of options, but this is generally how I like to record. And then as a final step, once I'm ready to record the final output, everything's set perfectly, I actually like to get rid of the jit.fps GUI object because it actually takes a lot of frame rate data just to process our frame output. So once you know what it is, you can just get rid of it and you're going to get a little bit better frame rate. And finally, there's this presentation mode icon button, which if we click that, it flips into presentation mode. I talked a little bit about presentation mode in other videos. It basically is just like the final UI output that you want to show. If you were sharing this patch, nothing's been added to presentation mode, so nothing's showing anymore, but don't worry, the code is all still here. The reason why I like to flip into presentation mode before recording my final output is because if you do that, it's going to give you better frame rate data as well. So now we are probably outputting at the highest possible quality that we could for this video, which we can now record in the Siphon Recorder app and get really just cool visual effects all around out of Max MSP at the highest frame rate possible, all thanks to Jit.world. And hopefully that makes sense to you guys. If it didn't make sense, please leave your questions in the comments down below, and I'll do my best to try to answer them when I can. If it did make sense to you, please remember to like and subscribe to this video because that's how I know that I'm doing a good job and you guys are enjoying these videos. And as always, there's also my Patreon, which I am using to share extra, more in-depth tutorials about ideas. And I also just started a live coding audio-visual programming series. If you know me and my work, that is one thing I do a lot, is I make a lot of audio reactive visuals in Max MSP. And I decided to do a live coding series on my Patreon where you just watch me make something from start to finish. And hopefully it's a little educational because you get to watch all my secrets and how I perform and how I think about things. And if that sounds like a fun time to you, go ahead and check those videos out over there as well. But again, always thank you for coming and thank you for watching. And I'll see you guys in the next video.